Welcome back. I'm Silas Gibbs, Engineering Manager at Duotech Services, and I'm here again with Sarah Loeffler to talk about some of the mechanical designs and simulation capabilities that we have here at Duotech. We talked a couple of times about our mechanical models, our mechanical design, and our manufacturing capabilities that we have. We really didn't get to talk too much about the software tools that we use and what those are able to do with us, do for us as we do our different designs and iterations here. We talked about the fact that our software allows us to build 3D models of the components. Once we get those 3D models together, we can put them together into assemblies. What are some of the things that we can do with those assemblies once they're completed?
Once assemblies are completed, a lot of times you need a drawing or something as documentation goes, and so you can easily pull CAD models into drawing packages and do all the drawings you need. You can do assembly drawings that'll put together explodes of assemblies that you've put together in CAD, so you can specifically see, this is how this thing should go together, and that's really helpful for fabrication work instructions and other things where like just a visual is helpful.
Yeah, probably my least favorite part of doing designs is writing the documentation. So anything that makes that easier is definitely okay in my book.
Absolutely.
With the drawings, that's helpful for producing documentation. Sometimes we do send parts out to other vendors, and so we'll create those drawings to give to them. And we use the drawings for inspection of the components as well as part of our AS9100 production process. But during the design process, do we use those assemblies for any other analysis?
Yeah, a lot of times, just even during the design process, you want to analyze your design and make sure that it's meeting the requirements that you've said that it will meet. And one of those ways is by using FEA analysis, which is finite element analysis. And that basically breaks the surface of a design part into a mesh that it is going to analyze in a simpler way using a lot of calculations. And so this software easily, you can put different requirements in, such as forces or pressures or other things, stresses and things that you would have on your design. And it will calculate, different things like stresses and strains and, where you see high stresses and high strains. And that's very helpful during the design process because you can look at that and say, well, I need to modify my design a little bit to, take out this stress a little bit more or, just tweak it a little bit so that it meets those requirements.
Right, so FEA is primarily a strength analysis.
Yes.
And we're able to use that to both optimize, put metal or material in where it's needed in the design, or to take metal out in places where we don't need it because it's not necessary anymore. Okay, so strength analysis, that's helpful. What else?
Right. And then another one that's really helpful, especially in our business where we're doing a lot of electrical things that produce a lot of heat, is flow analysis. And that basically, for our purposes, we use it a lot of times to simulate, this is the airflow through an enclosure where we may need to cool something. And so just having the ability to basically simulate that, components that may have a lot of heat and, pressure, air pressure that you are putting into a unit in order to cool it past, fins, or it gives you a lot of great analytical information about that these are the parts of the system that get hot. These are where it's cooling down very nicely. This is the kind of pressure that's in the system, and those are all good to know when you're designing those kind of things.
Yeah, so evaluating heat sinks, making sure that the right design choices have been made, and making sure that the system is going to operate in a variety of environmental conditions, because not everything is always at room temperature, sea level, and so you can do those simulations across different ambient temperature ranges as well. So we're able to basically build the model, build the part, and analyze the part without ever having to build the component, and so be able to find potential errors or potential problems early on in that process without going through the work of constructing the piece in the first place. So those are all pretty helpful things to make all the pieces of that work together. So when we take the requirements from the customer, whether it's for a structural piece that needs to have the strength requirements that it needs to have, or if it's just an electrical enclosure that needs to keep everything sealed up and dry and cool, then we're able to work those on both ends of the job with that. Because of our mechanical engineering department, Duotech Services is able to offer a wide range of design and manufacturing capabilities. We do have a wide range of manufacturing capabilities in-house, sheet metal, machining, 3D printing, and we have contractors that we work with for larger systems. Tons of steel we've had worked before with designs that are here. So our mechanical engineering team, as part of our engineering department, is able to bring these services to our customers in a timely manner that will meet the requirements within the budget and schedule constraints that our customers have. Thanks for joining us for these videos, Sarah. It's been informative, and we hope that you'll come back, visit us on our website at duotechservices.com, follow us on Twitter if you have any questions or want to find out more.